Well, students, in this video, I will introduce you to an online platform called Colab, where you can write and execute a Python code. Why Colab? Because with this interface, you can write and execute a Python program without installing any software on your personal computer, and also you can document the methods nicely in one single file, and your code can also be incorporated in that file where you can also execute it. So in that way, it is very interactive and very comfortable. Let us try to understand how to get into the Colab and how to use it step by step. First, log into your Gmail account and go to your Google Drive. In your Google Drive, you click on New, which is on the left top of your browser, and click on More. Sometimes you can see the Google Collaborator, which is what in short called Colab, is shown in this menu itself. If it is not so, then you can click on Connect More Apps. And then choose the collaborator. This is what is called the Colab. So just click on the collaborator and then install it. This will install the Google Collaborator on your Google Drive. Nothing will be installed on your personal computer. It will be installed on your Google Drive. And now you can use the Colab by getting once again into the new and then more. Now you can see Google Collaborator will be sitting in this pull down menu. You click on this. Well, it opened the Colab window. Here you can see that your cursor is in a field where you can write Python codes, and whatever you write will be saved in the file whose default name is untitled 0.ipynp. ipynp is the extension for Python codes developed on the Colab interface. Let me zoom and show you. You can always change this file name. Say, for instance, I will explain you how to write a small code to define a function and plot its graph. Therefore, I will name this file as function plot, and the corresponding Python code can be typed in this field. Before getting into the Python code, I will also explain you how to incorporate text into this program. There are two tabs in this window. One is for code and another is for text. Let me first show you how to incorporate text and then go into the code. So to incorporate text, we have to click on this plus text button, and it will bring a text window like this. Well, I don't want this code window which opened by default. Therefore, I will delete this. We will come to it later, and I will start my document with text. Let's give the title of this document as plotting the graph of a function. So to give this title, you just have to click this TT. You can also make this title bold by just highlighting the text and pressing B here. You can see whatever you type in the text window, it is compiled and shown as a document on the right hand side of this window. Let me just add some text here. Say I can just say in the form of an algorithm. I will say that the input for my program are going to be a function for which we want the graph. Well, I'm using the LaTeX commands to generate this document. Then I will go to the next line. I also want to take an array of X values at which I want to plot the graph. And the output is going to be a graph with X axis as the values given in the array X and Y axis as the corresponding function value. So once you have finished typing your document, you can exit this window by pressing Shift. Holding the Shift, you can press Enter to come out of the window. It will automatically open another window with the code interface. If not, you can also click the code and open a new code window. Now let us try to write a Python code to plot the graph of a given function. First, let us define a function. For that, the format is f equal to lambda lambda x. So you can now give any expression here. For instance, I would like to plot x square plus 3x minus 5. Now I have to generate the array for x. Let us say we will plot this graph in the interval -3 to 3. Therefore, I have to generate an array which runs from -3 to 3 with certain step size. Say its format is x is equal to arrange -3, 3, 0.05 say. Now this command arrange is something which is not directly inbuilt in the Python code. You have to import an external subroutine for that. So let me add this import. So this subroutine is called numpy. So you have to now type numpy dot arrange. Now in this numpy, you have a command called arrange, and that will make an interval -3 to 3 with the step size of 0.05. That's what it says. So if you are lazy to type numpy fully, you can also make a shortcut for that. You can also put as np, and then you can simply write np here. Now that will generate an array which goes from -3 to 3 and step size 0.05. Now we are ready to plot the graph of the function, provided if you have already generated the function values. Let's see, y-axis is equal to, now you have to send each value in the array and get its corresponding function value. That is very simple. You just have to put f of x, that's all. Now what it does is it takes this array x, and each coordinate of this array will be supplied to this expression, and the corresponding value of this expression will be stored in the corresponding coordinate of y. Therefore, y will also be an array with size equal to the size of the variable x. Now we are ready to plot the graph of the function f. For that, the command is plot x, y. Again, the command plot is not inbuilt in Python. You have to import another subroutine which contains this plot command. Again, we will go back to the first line. You can type this line anywhere before the command comes. But to have a clear understanding of the program, let us put all these import commands at the beginning of the program. Import, and the name of this plot subroutine is matplotlib.pyplot. Again, every time we need not type this full name. Therefore, I will just make a shortcut for this, plt, and now come back and put plt dot plot of x, y. To have a very neat look, you can just put certain lines to say that these are just import commands and these are the input commands. Anything which you type after a hash will not be executed by the Python code. Therefore, you can just put a hash and type whatever you want. This is the text within the program, whereas the text we wrote outside is just outside the program, and that can be typed in LaTeX format if you want. But here you just type in the ordinary text format. Okay. So to run this program, you just have to click this play button. You can see once I click this, you observe that there will be something happening here. Let us see what it shows. Let me click this play button. You can see that something is happening here. It is allotting a server space for us to run this program. It means the Colab is now giving us a server space in their server to run this code. So first time it will allot some memory and the processor for running this code. So therefore, when you click the program for the first time, it takes few seconds to do that. From the next time onwards, it will run the code more faster. Well, the program successfully ran and it has plotted the graph of the function. There are many things that you can do with this graph. You can just Google and learn more. The aim of this video is to just introduce you to this nice interface called Colab, where you can develop Python programs more efficiently. Well, now the question is where this file functionplot.ipynb is saved. It is saved in your Google Drive. Let me close this program window and go back to my Google Drive. You can see that this file is saved in your Google Drive. Sometimes it is saved in a separate directory, but with me, it is saved in the home directory of my Google Drive itself. Next time when you want to reopen this file, you just come to your Google Drive. You can again go through this new and then open it there, or you can simply double click here to open this file. You can see that by double clicking, I once again came back to this program file.